Dear students, in today's class we will see classic problems of synchronization. So here first problem is bounded buffer problem. Okay, see, this bounded buffer problem is similar to our day-to-day life event, that is withdrawing the cash from the ATM. See, in this ATM, some cash will be there, and customers of a bank will visit that ATM, and they will keep on withdrawing the cash. So once the cash is completely withdrawal and ATM machine becomes empty, then again bank employees will come and they will put the cash in that ATM. So here the bank employees are nothing but producers, and the public who is withdrawing the cash is a consumer. So the duty of consumer is to make the ATM machine empty, and the duty of consumer is to fill the ATM machine. The same example is taken here. That problem is called as producer consumer problem. Okay, so we assume that the pool consists of n number of buffers, and each buffer is having a capacity to hold one item. See, here one variable is there, mutex. Okay, so this mutex semaphore or mutex variable provides mutual exclusion for accesses to this buffer pool, and it is initialized to this value 1. Okay, mutual exclusion means any one buffer can be used at a time. The empty and full semaphores, these two are also variables. Empty semaphore is nothing but empty variable, and one more variable is a full. So these variables count the number of empty buffers and number of full buffers. The semaphore empty is initialized to n, and the semaphore full is initialized to 0. It means that initially the empty is initialized to n and the semaphore is initialized to 0. It means that the full is initialized to 0 means what? So there is no any process, and empty is initialized to n means what? There are n number of processes. So there is this buffer is not empty. Okay, so and buffer is not full. Its meaning, the code for producer is shown in this figure 2.15, and the code for this consumer is shown in figure 2.16. We will see the figures. So this is code for producer process, and this is code for consumer process. So first we will see the structure or code for producer process. Do so first we write produce an item in next producer. Okay, so produce an item in a next producer, and wait empty, wait mutex. What it means, already we have seen these two operations, wait and signal. Wait decreases or decrements empty. Okay, so empty minus minus, and wait decrements mutex also, mutex minus minus. Then add next producer to buffer. Okay, then signal mutex and signal full. So signal is nothing but increment, so mutex plus plus and full plus plus, so while true. So this is a code for producer process, and this is a code for consumer process. Do wait full. Okay, wait means what? Full. So consumer's duty is to make the buffer empty. So here wait is nothing but decrement. What it is decrementing? The value of full it is decrementing, like a full minus minus, and it is also decrementing mutex, mutex minus minus, and remove an item from this buffer to next consumer, and signal mutex. So mutex plus plus, signal empty means so empty plus plus. So here consume the item in next consumer. So while true, these are the codes for these are the codes for producer and process, producer and consumer. Okay, so here there is a symmetry between this producer and consumer. So we can interpret this code as the producer producing full buffers, correct? Producer is producing full buffers, and who is using these full buffers? Obviously consumer is using these full buffers, and this consumer is producing empty buffers, and who is using these empty buffers? Obviously for producers. Okay, now next problem is a readers writers problem. So see here, if a database is shared among n number of concurrent or parallel processes, then some of these processes may want only to read that database, and some processes may want to update this database. So how they update this database? It means that they want to perform both reading and writing operations on this database. So here we will differentiate between these two types of processes by calling them as first one as readers and second one as writers. So obviously if two readers access the shared data simultaneously, no effects will be result, no adverse effects will result. It means there will be no any side effects, okay, on the result. So but here if a writer and some other processes and other process, either it may be reader or a writer, access the database simultaneously, then the confusion may occur. So whether the process should be given to writer or whether that process should be given to reader. Okay, so to ensure that these difficulties do not come, or to avoid these difficulties, we require that the writer have exclusive access to shared database while writing to the database. So if he wants to write the database, he should have a complete exclusive access to that database. Okay, this synchronization problem is called as readers writers problem. So readers writers problem has different forms or variations. So all these forms involve priorities. In that one, simplest one, that is the first one, is called as first readers writers problem. It needs that no reader be kept waiting unless a waiter has already obtained permission to use the shared object. That is, no reader should wait for other readers to finish simply because a writer is waiting. Okay, so the second writer problem requires, once a writer is ready, the writer performs its write operation as soon as possible. That is, if a writer is waiting to access the object, then no new readers may start reading. A solution to these any one of these problem will result in a starvation. Starvation means they are eager to get. Okay, then in the first case writers may starve, and in the second case the readers may starve. So here the structure of a writer process we have given, that is do, wait, write. It means wait means what? Write. Write minus minus, writing is performed, and signal write means signal plus plus, that is write plus plus. Okay, so here next is structure of reader process. Do wait mutex, it means mutex minus minus, and read count plus plus. If read count equal to 1, then wait write, it means write minus minus, and signal mutex, it means mutex plus plus. Then reading is performed here, and wait mutex is nothing but decrement the value of mutex, it is mutex minus minus, as well as decrement the value of read count, that is read count minus minus. Once this read count value becomes to 0, then signal write, it means write plus plus, then signal mutex, that is mutex plus plus. Okay, so next problem is very interesting problem, that is a dining philosophers problem. So just imagine that there is a dining table with 5 chairs, and five members sitting on those chairs, and 5 plates are kept on the table, but just beside of each plate there are only uh, two sets of uh, chopsticks. So it means that a user or a philosopher or the person who is eating, so he can take only chopsticks from his right side neighbor and one more chopsticks from his left neighbor. Okay, so then if it happens like this, so here it is. So here this is 1, 2, 3, 4 and 5. If the philosopher number 5 wants to eat this food, he has to take a chopstick from right side and he has to take chopstick from left side. So but if this one wants to eat the food, then he cannot take this chopstick, because already fifth philosopher has taken that chopstick. He can take only this chopstick. If this two wants to take a chopstick, then he cannot take this one, he can take only this one. Okay, like this, at a time only one philosopher can eat the food. So this is a dining philosopher's problem. Consider 5 philosophers who spend their lives thinking and eating. Okay, so they always do only 3 things. So first thing is thinking, and second thing is eating, and third state of these philosophers is hungry. Thinking, eating, hungry. Thinking, eating, hungry. The philosophers share this circular table surrounded by 5 chairs, each chair belonging to one philosopher. So in the center of this table there is a bowl of rice is there, and the table is laid with 5 single chopstick as shown in that figure. In this figure, when the philosopher thinks, she does not interact with her colleagues, right? So whenever we start thinking, we will be not aware of our neighbors, so we do not interact with our colleagues. So similarly here, a philosopher thinks whenever she does not interact with her colleagues. From time to time, this philosopher gets hungry and tries to uh, pick the chopsticks, 2 chopsticks that are very closest to her, the chopsticks that are been between her and her left side and her neighbors. A philosopher may pick or take only one chopstick at a time. So obviously she can pick a chopstick that is already in the hand of a neighbor. So when hungry philosopher has both her chopsticks at the same time, she eats without releasing the chopsticks. So when she is finished eating, she puts down both of her chopsticks and start thinking again. Okay, so for this problem, uh, so we have to find out a solution now by using monitors. So monitor is nothing but uh, uh, we will study this monitor in next video.